Assalamualaikum warahmatullahi wabarakatuh. Today, our group will be presenting our group project title, which is Protecting User Data in Operating System for CS207. So first, we're going to start with our introduction. The operating system is often called the silent engine of our digital life, but it is far more than that. It is actually the primary custodian of user data. It acts as an essential bridge managing the communication between the high-speed hardware and also the complex software application we rely on. In our current environment, where every aspect of life is digitized, protecting this data has evolved from a technical preference into a fundamental necessity. We are witnessing an era of advanced persistent threats. Modern attackers, state-sponsored actors, or organized cybercrime syndicates now deploy ransomware and also rootkits designed specifically to burrow into a kernel-level vulnerabilities. They don't just attack apps, they attack the foundation. When OS is compromised at this level, the confidentiality, integrity, and also availability of all data are shattered, leading to the catastrophic financial loss, legal liability, and also a long-term operational paralysis. So first, we're going to start with our introduction. The operating system is often called the silent engine of our digital life, but it is far more than that. It is actually the primary custodian of user data. It acts as a
Assalamualaikum warahmatullahi wabarakatuh. My name is Norehana binti Mat Taufik. My student ID is 2025105927. I'll be presenting the OS analysis. To understand how we protect system, we must understand how they are breached. At its core, the OS functions as a strict gatekeeper. It enforces memory protection and establishes rigid boundaries, specifically the user mode and kernel mode separation, to keep processes isolated from one another. However, attackers are constantly evolving their method, like using privilege escalation, which attackers often gain a small non-privileged foothold and use it to exploit vulnerabilities to gain root or system access, effectively becoming the administrator. The next one is memory vulnerabilities. Techniques like buffer overflows continue to haunt us. By intentionally providing more data than a buffer can handle, attackers can override adjacent memory to execute malicious code. And next one is insecure configuration and synchronization. Misconfigure default setting are an open door. Furthermore, complex multi-thread operation create synchronization errors or race conditions, where an attacker forces the OS to perform operation in an unintended exploitable order. And the last one, we have seen the real world fallout like the Shaman Wiper malware, or the global spread of NotPetya, or the Ukraine power grid attack. These aren't just IT incidents, they are lessons in what happens when OS level security fails, resulting in physical hardware destruction and total network-wide collapse.
My name is Faisal Matua and I will present about ethical consideration. So firstly, for privacy and data protection, developers have a responsibility to protect user personal data. Security features such as encryption, authentication, and access control should always be implemented to prevent an unauthorized access. So secondly, for transparency, organizations should clearly explain what data they collect, why they collect it, and how it will be used. So when users understand this practice, they are more likely to trust the system. Lastly, for administrative responsibility, a system administrator have privileged access to sensitive information. Therefore, they must use this access only for a legitimate purpose. Follow organizational policies and maintain audit laws so that every action can be traced and accountability is ensured. Thank you.
As IT professional, our ethical mandate is defined by our commitment to the CIA trait: confidentiality, integrity, and accountability. This is not a set it and forget it career. We have a professional obligation to commit to continuous lifelong learning to keep pace with evolving trade. If you stop learning, you stop protecting. We also have to balance the security with the human experience, ensuring our security measures don't stifle the right of the user or make system unusable. Our personal responsibility is the first line of defense. It involves reporting vulnerability immediately through the proper channels and rigorously following established security protocols. Even when it's inconvenient, how we handle data today dictates the security of the infrastructure of tomorrow.
Now we can move to the last part, which is conclusion. To wrap up this, we must accept the harsh truths that data integrity cannot be achieved through the superficial one-off patches. It requires a layered defense strategy that is built directly into the kernel and a memory management levels. We need to shift our strategy to include first the immutable operating system, which is mean moving toward a system that cannot be modified after deployment to prevent the persistent rootkit infections. Next is zero trust of architecture, following the never trust always verified model, which includes the total elimination of persistent local and administrative privilege. And the last one is micro segmentation, dividing the network and OS resources so that the breach in one small component cannot cascade into a system-wide disaster. Security is not a static objective or simple checkbox. It's in an active continuous process of adaptation and defense. By hard-coding resilience into our configurations, we fulfill our ethical mandates as stewards of the digital trust and ensure our organization and can maintain the operational continuity regardless of the threat they face. Thank you. Now we can move to the last part, which is conclusion. To wrap up this,
I just had to let you know you're